Okay guys, this is Essex electrical training. This is sort of lesson number 2 in our series of inspection and testing. And the first thing we're going to look at is safe isolation. Okay, so this is a typical installation that one of our guys do. Bit of a mishmash, I know, but we try and give them practice at everything. Also, I'll just point out a couple of things. Obviously that is in twin and earth. It's a commercial installation, so you wouldn't usually be mixing twin and earth in a commercial installation, but when we go on to the commercial, we like to keep them reminded of domestic wiring as well, so that's why we include it in there. But anyway, this is, we're going to do safe isolation of this entire installation, if you like. Here it is, it's controlled from there, all switched on, but all the breakers are off, the main switch is off. We've got 2 AFDDs, surge protection and all that sort of thing. So the first thing that they ask you to do is you're really sort of familiarising yourself with the installation, which is what I'm just doing. They want us to isolate the whole thing, which is fine. And colleges, and I've got to say, even some AM2 centres get a bit confused about the first thing that you're doing with safe isolation, because they say you must seek permission to isolate. Okay, that's fair enough, but they interpret it as a permission to isolate. So yes, you have permission to isolate. That's not what it's all about. Okay, what we are as electricians, we are notoriously bad at informing people. So what it means is seeking permission to isolate. You're saying, oh, I'm just going to turn the power off, mate. Is that all right? They'll say, yeah, that's okay. But you're not spelling it out to them. And then what they'll do is, oh, my computer's gone off. You know, what it means, seeking permission to isolate, is spelling out what you're doing. Is it okay to turn the power off? What it means is this is not going to be working. The lights in the toilet are not going to be working. You won't be able to operate your machinery. And try and give them an estimate of time. So that's going to be like that for about 2 hours. That's what seeking permission to isolate really means. It's spelling out what it means. Also, they get confused when they turn around and say most of the assessments that you do will be an installation certificate, an EIC. Well, then they say, oh yeah, you've got to seek permission to isolate. No, you haven't, because an EIC, you are putting it into service. It is off. It's already isolated. You're the one who's putting it into service. So why should you seek permission to isolate when it's already isolated? So then you say, oh, well, what they must mean is a condition report then, because there you'd be, you might be doing selective circuits. So then you have to assume that it's a condition report that is small enough that you're doing the whole installation, okay? And therefore then if it's a condition report, then you should be filling out, after doing safe isolation, a condition report and not an installation certificate. But anyway, let's forgive all that. Let's say that most of the time for your assessments and right, you'll be doing an installation certificate and ask for permission to isolate. Yes, it ticks all the boxes, but I'm just telling you the reason why. But anyway, there it is. So what we're going to do is we're going to carry out safe isolation of this entire board. If they wanted me, they said, oh, that switch is faulty, and please don't call it a linked switch. It's not a linked switch. It's a double pole switch. A linked switch is, you usually get it in industry, where you have 2 distribution boards next to each other and the 2 main switches are physically linked, because one of the distributors depends on the other one being isolated. But anyway, we won't go into all that. So it's a double pole main switch. So it's in the off position, which you would expect, because it's you're going to do the testing and put it into service. If you was going to change that switch, then obviously carrying out safe isolation of main switch is no good. You'd have to carry out from here, okay? So that whole board is isolated. But what we're doing is we're doing all the circuits in this board, so therefore we're going to carry out safe isolation of this board. Okay, so let's do it. So here we go, guys and girls. We're going to safely isolate this board. We could we'd safely isolate in the whole thing, so I'm going to go on the main switch. And the thing is all about time. It takes you no extra time to put the safe isolation on first. Okay, so there's no danger. I mean, we're doing safe isolation. because we're, to ascertain whether it's all dead, and we're not sure at this stage. I mean, it's pretty obvious it is, but nevertheless, that's why we're doing safe isolation. So I'm putting the clamp on the main switch. I could put it on any one of these circuit breakers as well, if it was just one circuit. Remember, initial verification could be just one extra circuit or one new circuit in this board. But in this case, it's the whole board. So I put my lock on, do that up like that, switch it on, and then obviously I'm putting the key in my pocket. There is a famous story where a guy was doing his AM2, didn't put the key in his pocket, and they let him do the whole thing 2.5 days, and told him at the end that he failed because he didn't put the key in his pocket. But anyway, there we are. That's the safe isolation on. So now I'm going to take the cover off. So it'll come off with the safe isolation on. It's designed to do that. Put those on the top. Spin it round, and safe isolation comes off. These are a pain in the arse while you're testing, so I'll take that out as well. Okay, so there we are. So as far as we know, it's all safely isolated, but we haven't proved it, okay? And that's what it's all about. So, when you're going for assessments, you're going to do it in a different way. By the way, I will say that this is one of our guys, so this is the first time I've seen it. So visually, I would say, these could be a bit better, but I'll probably correct those as I go. And he hasn't put a plate over there, so theoretically it would fail because it has failed at your visual inspection. That it doesn't comply with the IP codes. But what we'll do is we'll carry on, okay. And what I'll do is I'll put a plate over that and cover that up. Anyway, and tidy all these up. It's generally a bit untidy, but yeah, there we are. Okay, so safe isolation. So what you're going to do is use an AVI, approved voltage indicator, or an AVT, same thing, approved voltage tester. Applies to GS38, which is a recommendation from the Health and Safety Executive. It says that the two ends should be easily identifiable from each other, that the lead should be not too short and not too long, that they should have finger guards so that your fingers can't slip down to the terminals, that they should have inline fuses, and that the exposed tips should be not more than 4 mil, but preferably less than 2 mil. Now, when I come on to doing continuity testing, there'll be a refinement on those tips because every electrician will tell you, if you can comply to those, you can't get them in some modern terminals. But anyway, we'll come to that when we come to it. So it is single phase, so the live conductors will be at the top of the main switch. If it was 3-phase, they'd be at the bottom. Okay, so we've got to test that the circuit is dead, so I'm going to take this cover off. Put that down there. Now put it on there. No, put it down there. And what I'm going to do is, it says to make sure this is working. There actually is no requirement on that. If you go through it and then when you reprove it and it's not working, then you've just wasted your time. But anyway, what we do is you can do it 2 ways. Now, you can prove that this is working, or even reprove it by going onto a known source, which in this case will be at the bottom, at the top. So there is that's live, and then, or you can do it on a proving unit. Now, I don't know many electricians that carry a proving unit around. I'll tell you for why. Because if you're doing testing, if you're doing initial verification, then you need a live source to do live testing. If I didn't have that at the top of the main switch, then I couldn't do the live test. Okay, so you've got to have a live source. So most electricians will prove this on a known source, but colleges and AM2 centres and they'll always give you a proving unit, so I would use it. So a proving unit, you're just sticking there, it's going to give you a signal that is, it's not like a neon screwdriver. A neon screw don't need hardly any current, where this is just needs a little bit of current to make the lights work, so it won't give you a false reading. So I've proved that it's working. So now what I'm going to do is I'm going to go on the dead side of the main switch. This is getting in the way of the thing a bit, but anyway. So what I'm going to do is, first of all, I'll go between line and neutral. At line and neutral at the bottom, that's dead. Okay, so there's no feed there, which is good. Then I'm going to go between line and main earth terminal. So that's dead. And then I'm going to go between neutral and the line earth terminal, and that's dead. And then I'm going to reprove the unit. As I say, if you're doing your assessment, do it on the proving unit, and that says yes, that's still working. All the 4 lights are up there. Or you can do it on a known source, and that tells me that the proving unit is still working. So therefore, no risk, all the safe isolation is on. This is all dead, everything's dead. The only live part would be those 2 terminals there. And you, as I say, when we come on to doing the live tests, you'll need those for doing live testing. So this is single phase, a 3-point test. Line to neutral, line to earth, neutral to earth. Then reprove the unit. So what we've got to do also is you've got to do 3-phase testing, which we'll go on to a 3-phase board. So guys and girls, this is a typical 3-phase or a mock-up of a 3-phase installation. There we've got the main switch that will kill everything on that wall. Main switch feeds a bus bar chamber. Please don't call it a buzz bar. It is a bus bar, Latin omnibus, carrying bar. That's what it is. It's not a buzz bar. But anyway, there we are. So 3-phase board. 3-phase board looks like it feeds that 3-phase motor. Don't take any notice of that. That's just our fault board. What we put faults on with those. And then there's the lighting, and then there's a MIMS. Looks like a well, we'll see what it is when we look at the board. But yeah, we're familiarised ourselves. This is the point of isolation. Main switch, bus bar chamber. That looks like it's separate. So open up the board, and basically what you've got is a main switch. It's all labelled up, and it says main switch, what does it say? It says a power track. Now that's the power track. Our students put in power track and ladder rack, and that's not been done yet, but that's one will be power track, one will be ladder rack, and then we've got ring final, so that is a ring, so that's that one. We've got fuse spur, so it's an alarm, and we've got lighting, and then sure enough we've got a 3-phase motor, which is that one. So again, no reason why you can't put your safe isolation on first. If they wanted me to change that main switch, then I couldn't isolate it from there. I'd have to turn it off from the main switch, so that is fully isolated. If I turn that main switch off, which is in the off position, then it would still mean that the bottom of that switch would still have 3 phases. So what I'm going to do is I'm going to apply the safe isolation. If you're sometimes you'll come across in the safe isolation have one of those, and that is there's usually multiple locks in there for all different. It might be the safety officer, might be the head of that section of the site, and then you. These do get messed around a bit, and they do carry labels, but sometimes the labels fall off and you've got to track down who put the lock on, and it's a right pain. But anyway, so but ours is just us. So what we're doing is we're putting the safe isolation on, and it's going to be on, as I say, on the main switch. It's in the off position. Okay, if it was in the on position, remember to turn all the breakers off first, so that there's no load going through the main switch. You don't really want that. It's not designed to disconnect full load, really. So then I'm going to put on, we'll use this lock, doesn't matter. So I'm going to put that one on there like that. Key in my pocket, safe isolation on. So now I'm going to take the lid off. So it should all be safely isolated. So now I'm going to turn it, and off comes the cover. It's all safely isolated as far as we know, but what we're going to do is check it. All the live terminals are behind that cover. Again, usually this cover will come off with the safe isolation in place. So that'll pull off, and there's your live terminal. So remember, 3-phase, so it's live at the bottom, and all these should be dead, but we are going to absolutely make sure. And just like the single phase, I can test this on a known source, which will be at the bottom. Main switch on. Which will be at the bottom. It should be dead at the top. Or I can do it on a proving unit. So there's the proving unit. Test it like so. And it gives us all the lights on that AVI or AVT, so we know it's working. So with 3-phase, single phase was a 3-point test. With 3-phase, it's a 10-point test, okay? So get yourself into a routine, do the same thing all the time, doesn't matter which way you do it, but just get yourself into a routine of doing the same thing all the time. So what I do is main earth terminal. There's a main earth terminal there. Should put that on first. So main earth terminal first, and then I'm going to go between L1, nothing. L2, nothing. L3, nothing. Neutral to earth, nothing. So that's 4 tests. Then what I'm going to do is go between the neutral and L1, nothing. L2, nothing. L3, nothing. That's 7. And then what I'm going to do is go between phases. L1 to L2, L1 to L3, L2 to L3, making it a 10-point test. And then I'm going to reprove the unit. Vitally important that I make sure that that tester is still working. And there's all the lights on there. Fantastic. I could have done it on a live source as well. So there is there's the neutral. So I should have 3 lights on that one. It doesn't matter which way you do it. And then go between phases, and I have 4 lights. It's okay. So that is safely isolated. So all this is dead. All at the top of the switch is all dead. And it's all marked up as well. This is a bit funny. It's all marked up on the inside as well. That's good practice. Please do that, so that when you take the board cover off, you've marked up the breakers, so it makes it easier. Remember who you're working for. You're not working for your boss. You're not working for the customer. You're not working for the country. You're working for the electrician that follows you. Okay, make it easy for him or her. That's who you're working for. So if you label these breakers up, even when he takes she takes the distribution board cover off where they're all marked, it's still got an indication of what the circuits are. So we've done safe isolation. That's all done. So the next one, we go on to continuity. Okay, we'll go on to continuity. That's the first of our tests, so that'll be in the next video. So I'll see you then.